One thing I do every year is a programming challenge called Advent of Code. One thing I like to do is look at other people's submissions and see if there's something I can learn from it. In this video, I'm going to take pieces of somebody else's code and do a sort of peer review of it. We'll see how we can use features of the Rust language to make this code even better. Let's look at this. This code is walking through a two-dimensional grid looking for the coordinates of a specific character in this grid. In this problem, it's a player location. The code initializes the value we're looking for to 0, and then uses nested for loops to walk through the grid. If the value stored in that grid location is the value we're looking for, then we set the current to the coordinate that we're at and break out of the loop. We're going to address a couple of issues in this implementation, and then look at how we can use Rust's iterators to solve this problem entirely. First, I'm going to replace the initialization and the setting of our current value to be an optional type, because it's impossible that we may not find this value, and we don't want 0 to be the default value of the player location. At the end of our search, we can then unwrap that option type, propagating an error value if there is no current value. We have an early exit condition, but it's not working right. It only breaks out of the inner loop. So to fix that, Rust has a way to tag the top of a loop and break out of the most nested loop that you want to break out of. This next one is more of a personal choice, where I like to wrap the logic of finding a particular value into a block. This tells the future me that everything inside of this block is done to extract out the current player location. You may not have seen this the first time around, but there's a subtle bug in this. If you look at that, in the inner for loop, we're taking the 0th element of the grid and getting the length. This assumes that the grid is rectangular, and every row has the same number of elements. To be correct, that 0 should be replaced with an I. This avoids a potential panic trying to get at the jth element of an array that doesn't exist. This implementation is now correct. However, using integers to walk through a container is problematic, as we've seen. A better way is using iterators. An iterator knows how to walk through its container safely. Enumerate adds an index to every element that it returns. In this case, it's the Y position along the row. Flatmap is a mapping operation that's performed on every element of the container. Since our container is actually a nested container, row is going to be another container that we have to iterate through. The value being mapped this time is an individual cell. The filter predicate's going to look to see if that cell value is the value that we're looking for. And if it is, it's going to return the XY, or in this case, a YX component. Combining iterators this way is a very powerful way to transform your data. Next, we'll return the first XY location found by this, which is an optional because it may not find any element at all. I use OK or else, just like we did before, to propagate any errors. Looking at these side by side, they look very different. But if you were to compile them and look at the assembly code, it would be virtually identical. The benefit of using iterators is that we don't have to manage both how we walk through a container with the business logic of what we want to do with each element. This results in less error-prone code and allows us to focus on the business logic of our application. And that's pretty cool. In the next videos, I'm going to show you how we can use iterators In the upcoming videos, I'll show how you can use iterators to better describe the problem to make the code more readable and more maintainable. Thanks for watching.